So we broke down the definition of what t-SNE stands for. Now let's dive into its inner workings. In this video, we will be looking at dimensionality reduction and local neighborhoods in t-SNE, and also explore t-SNE's potential limitations. Before we dive into its inner workings, I recommend you watch the t-SNE What's in a Name video to learn what it stands for first, or simply as a refresher. t-SNE is a visualization method that takes complex, multidimensional data and turns it into a 2 or 3-dimensional picture, showing similar things close together. Think of this as graphing a complex data set on paper to find clusters. The completion of this 3-part series will empower you with tools to visualize and explore your data sets thoroughly, using any language you prefer with confidence. First, let's look at a simple dimensionality reduction technique. Take this 2D view of a data set with 3 distinct clusters of data points. To reduce it from 2D to 1D, we could do this in one of 2 ways. We could project it to the x-axis. Imagine shining a light on the data so each point can cast a sort of shadow onto the x-axis. By doing this, we can get rid of the y-axis. However, when we do dimensionality reduction, the projection can cause one cluster to overlap with others, making it hard to distinguish with another cluster. Let's look if option 2 fixes this. Alternatively, we could project our points onto the y-axis. This will get rid of the x-axis. But projecting onto the y-axis leads to the same problem as option 1. But this time, a different cluster of points is obscured. So what is our end goal? If we project onto the x-axis, we want to see the 3 distinct groups as in the original dataset. Also, if we project onto the y-axis, we want to see the 3 distinct groups as in the original dataset. The original data can have any number of dimensions. So instead of a general view, let's see dimensionality reduction through t-SNE's eyes. The primary goal of t-SNE is to visualize high-dimensional data in a low-dimensional space by preserving local neighborhood relationships. However, t-SNE is not intended for feature selection or removing groups. It's a visualization tool to emphasize local structure, but it may distort global distances, leading to results like this, or this. Before we recap, let's do a brain teaser. Can t-SNE produce this? Leave your answers in the comments below. Also, be sure to visit our YouTube channel to find more videos where we cover various topics. Finally, don't forget to subscribe to our channel. It motivates us to create more content for you. We will end this video here and recap what we just learned. In this video, we've learned that t-SNE doesn't preserve everything in the data visualization process, but it prioritizes preserving neighborhoods to find similarities in the data. That's what the N in t-SNE stands for. To learn more, I recommend you watch the other t-SNE videos for review, or the other listed videos to understand different dimensionality reduction techniques.